Alright guys, welcome back. For the last week of school, we're throwing it back to chapter 10, graphing quadratics. If you remember, a quadratic equation is anything that is raised to a power of 2, any kind of polynomial. So the function describing the height of the rocket above is a quadratic function. A quadratic function can be written in the form of y is equal to ax squared plus bx plus c. Remember, that's just your standard polynomial that you're used to, x squared plus a number, x plus a number, where a represents the coefficient 1 or a greater value, but a cannot equal 0. This form of quadratic function is called standard form. So y equals ax squared plus bx plus c is standard form. Notice that this polynomial has a degree of 2, so it's being raised to the second power, and the exponents are all positive. The graph of this function is called a parabola. So anytime we graph a quadratic, so again, a quadratic is anything in the form of y equals ax squared plus bx plus c, it graphs in this U shape called a parabola, and it either opens up like a smiley face or down like a frown. That seems like a silly way to describe it. Easiest way to remember it is you know the way it's going to open based off of your leading coefficient, this a. If a is positive, so a positive value, it's going to open up like a smile. It's smiling because it's positive. Or if a is negative, it's going to be down like a frown. So easy way to remember it. Example 1 is when the graph opens upward. So like our first example where it's opening up like a smile. Here's our handy dandy graph paper. And we're told to use a table of values to graph this expression. So hopefully you can see past my hand. Example number 1. We have the quadratic y is equal to 2x squared minus 4x minus 5. And we're told to use a table of values, and they start with -2 and go all the way up to +4. We'll see if we do that many. But they're saying let x equal something, and then what does y equal? So if you plug in an x, you're going to get a y. So they say -2, -1, 0, 1, 2, 3, 4. All you do is plug in your -x squared anywhere you see x. And you can see, okay, we're good. So starting with -2x, y is equal to 2 times -2 squared minus 4 times -2 minus 5. We love working with negatives. Am I right or am I right? -2 squared is +4. +4 times 2 is 8. -4 times -2 is a +8. And then minus 5. 8 plus 8 is 16. 16 minus 5 is 11. So when x is 2, y is 11. And we have our first ordered pair. And we're just going to repeat the process now with -1. So y squared is equal to 2 times x squared. X is -1 squared. So y is equal to 2 times -1 squared minus 4 times -1 minus 5. -1 squared is +1. 1 times 2 is 2. -4 times -1 is +4. Minus 5. 2 plus 4 is 6. 6 minus 5 is 1. So when x is -1, y is +1. Going on with the 0. Y is equal to 2 times 0 minus 4 times 0 minus 5. Multiplication by 0 cancels out. So when x is 0, y is -5. Doing it with 1 now, y is equal to 2 times 1 squared minus 4 times +1 minus 5. 1 squared is 1, 1 times 2 is 2. 1, or -4 times 1 is -4 minus 5. 2 minus 4 is -2, or -2. -2 minus 5 is -7. So when x is 1, y is -7. You get the gist. I'm going to go ahead and fill in the rest of the answers for time's sake. So we have 5 and negative, or 2 and negative 5, 3 and 1, 4 and 11. And then you graph these the same you would under normal circumstances. So you just draw out a fairly substantial grid because we have a y value of 11, so I probably didn't even draw it high enough, but that's okay. So negative 2, 11, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's our first point. Negative 1, 1, negative 1, 1, 0, negative 5, 1, 2, 3, 4, 5. Then I have 1, negative 7, 1, then all the way down to 7, right there. 2, negative 5, 1, 2, negative 5, 3 and 1, so 1, 2, 3, up 1, and then 4 and 11, 1, 2, 3, 4, up to 11. And you can see that I have this kind of V shape, but we know because they told us it graphs like a U, so kind of bottom out or round out your bottom just like that and connect your points. And you've drawn your first parabola. Very exciting. And remember what I said, we knew it was going to open upward because 2 is positive. If your leading number is positive, then it's positive like a smiley face. If 2 were negative, it would have been frowning because it's negative. Such clever ways to remember things. I know, I'm brilliant. All right, on to the next page. At the very top right here, consider the standard form y equals 2x squared plus bx plus c. Notice that the value a in example 1 is positive and the curve opens upward. So again, they're saying it opens upward. The lowest point, or the minimum of the graph, is located at 1, 7. So if we're just looking at the graph and I were to say, what's your lowest point? At what point does your graph dip down the furthest? We would say, okay, right here. That's the lowest point. And this point happens to be 1, negative 7. Well, this point has a name. It's called the minimum. The minimum of a graph is only when you have a smiling graph, so this upward U, and your minimum is just the lowest point on your graph. So this is also called our minimum. Again, you have a minimum when you're dealing with upward-facing graphs. Now for example 2, we're going to graph a downward-facing one. I'm going to flip this over so we have a fresh piece of paper. And we have the quadratic y is equal to negative x squared plus 4x minus 1. And remember what I said, that if your leading a value is negative, it's going to be downward like a smiley face. They give us some x and y values. They give us negative 1, 0, 1, 2, 3, 4, and 5. Holy cow. We do the same thing. Plug in your x values for all of your x's, get your y. So y equals negative x, which is supposed to be a negative 1, negative 1 squared plus 4 times negative 1 minus 1. Negative 1 squared is positive 1, but I had this outside negative 1 that I have to remember. So it's still actually going to be negative 1. Again, negative 1 squared is positive 1. Positive 1 times that negative sign is going to be negative 1. Plus 4 times negative 1 is negative 4. Plus negative 1. Negative 5, negative 6. So when x is negative 1, y is negative 6. That's my first value. Repeat for 0. Y is equal to negative x squared, so negative 0 squared plus 4 times 0 minus 1, easiest one. Zeros cancel out, and I'm left with just negative 1. So when x is 0, y is negative 1. And then this is going to be the last one I do, but you know that we just repeat it all the way down. We're going to say y is equal to negative, because that pre-existing negative sign, 1 squared plus 4 times 1 minus 1. 1 squared is 1. 1 times that pre-existing negative sign is going to be negative 1. Negative 1 plus positive 4 minus 1. Negative 1 plus 4 is going to be 3. 3 minus 1 is going to be 2. So when x is 1, y is 2. Now I'm just going to copy down our table of values. But again, like I said, all you're doing is the exact same of plugging in your x values. So we have 2, 3, 2, negative 1, negative 6. And it's important to notice that when I graph it, I'm going to have this middle point that we're going to talk about in a little bit. The middle point is actually called your axis of symmetry. But after you hit your axis of symmetry, you end up having mirrored values. So 2, 3 is going to be my axis of symmetry. I know that because on my top and bottom of my 3, I have a 2 and a 2. A negative 1 and a negative 1, negative 6 and negative 6. Right here, if I fold my paper in half, my y values are identical. But anyways, we're going to go ahead and we're going to graph this one as well. Boom. All right. Should have made it up here higher, but that's okay. We have negative 1, negative 6. Negative 1, negative 6. 1, 2, 1, 2, 3, 4, 5, 6. 0, negative 1. Right there. 1, 2. 3, 2. 1, 2, 3. Up 2. 1, 2. Did I skip a point? I did. I skipped this one. 2, 3. 1, 2, up 3. 1, 2, 3. And now I'm at 3, 2. 1, 2, 3. Up to 2. I have 4, negative 1. 1, 2, 3, 4. Down to negative 1. And now I have 5, negative 6. 1, 2, 3, 4, 5. Down to negative 6. Right there. Curve out my bottom because it's a parabola, which means it has to be a U shape. Connect my dots. And that's my first negatively shaped parabola. Now it's important to notice, on our previous one we had this minimum value. We said, what's the lowest point of my graph? And it was at the bottom of the hump. Well, here, I still have the roundness of my hump right here, but it's now my tallest point. It's the top of this mountain, whereas before it was the bottom of my valley. And that's still an important value to us. What is the tallest point on our graph, or what's the center of our hump? Well, it was this value right here, 2, 3. 2, 3 is the tallest point on our graph, but when it's a downward shape graph, so when it's a negative U sad graph, we call that our maximum. We call it our maximum value. So to do a quick comparison, remember over here, when we graphed our first one, we had the smiling face with our lowest point. That lowest point is called the minimum. When we graph the downward facing parabola, we have the highest point. That highest point is called our maximum value. All right. Looking back in our book right here, notice that the value of A in example 2 is negative and the curve opens downward. So just like I said, negative opens downward. The highest point, or the maximum of the graph, is at 2, 3. The maximum or minimum point on a parabola is called the vertex. So this high point right here is called your maximum, but it's also referred to as your vertex. Same thing here. So both your maximum and your minimum, they're also your vertex. And the way you would hear that in conversation is a question might tell you to identify your vertex of your graph. So if they say, what's your vertex? You would say, my vertex is the minimum value of 1, -7 or something. My vertex is the maximum value of 2, 3. Moving on, parabolas possess a geometric property called symmetry. Symmetrical figures are those in which the figure can be folded in half so that each half matches the exact other. Think of a butterfly. one wing matches the other. Same thing can be said for a parabola, that if you were to fold it in half right here through your vertex, it would match perfectly. It would lie perfectly on top of each other. The fold line in this activity above is called the axis of symmetry for the parabola. Each point on the parabola is on one side of the axis of symmetry, and it has a corresponding point on the parabola of the other side. So again, just looking here, this is my vertex, it's my center point. I go down over 1. I go down 4 over 2, down 4 over 2. I go down 6 or 7, I think. I go down 9 maybe. Over 4. Over 4 again. It matches perfectly. If I fold this in half along this dotted line, they would rest perfectly on top of each other. That is our axis of symmetry. The vertex is the only point on the parabola that is on the axis of symmetry. So again, we said our vertex is this highest or lowest point, and it's the only point that rests on the axis of symmetry. It's the only one that the axis of symmetry crosses through, if you will. In the graph, which is now what they're showing right here, in the graph of y equals x squared minus x minus 6, so this graph right here, the axis of symmetry is x equals negative 1/2. The vertex is 1/2, comma, negative 6 1/4. So again, we have this minimum value right here, and they went ahead and put a dot there, and they're telling you that it falls on this coordinate or ordered pair of 1/2, then down 6 1/4. And then they say the axis of symmetry is your x value. So if you have to state it, you say my axis of symmetry is the x value of my ordered pair that states my vertex. So here, what's my axis of symmetry? My axis of symmetry is x equals 2 because of my ordered pair starts with 2, 3. All right. But there is a way to solve this without actually graphing. And that's what we're going to be looking at on the top page. Again, if the question were to say, what is your vertex? What is your axis of symmetry? And you don't actually want to graph this whole thing to get there, there's a shortcut, and that's what we're going to talk about now. All right, key concept right here. The equation of the axis of symmetry for the graph of y equals ax squared plus bx plus c is x is equal to negative b over 2a. So your formula for your axis of symmetry, so axis of symmetry is equal to x is negative b over 2a. Remember, your axis of symmetry is just the x value of your ordered pair. So it doesn't tell you your vertex. This is not an equation to tell you the vertex. It's just an equation to tell you your axis of symmetry, which is the x value of your vertex. So you still have to find the y. But so your axis of symmetry of an ax squared plus bx plus c equation is x equals the negative version of b over twice your a value. So let's look at example 3. You can determine the information about a parabola using this equation. Vertex and axis of symmetry. Consider the graph of y is equal to negative 3x squared minus 6x plus 4a. Not 4a, just 4. A. Write an equation of the axis of symmetry. So easy enough. We now have this handy dandy formula. So example number 3. A. So our equation is y is equal to negative 3x squared minus 6x plus 4, and we're just going to plug in our values to this equation. Well, what's my b value? B value here is negative 6, so I'm going to rewrite my pre-existing negative sign, and then negative 6 over twice my a value. And my a value here is -3. So I have -6 over 2 times -3, which is -6. And I have this pre-existing negative sign. So -6 over -6. -6 over -6 is +1. A negative over negative becomes a positive, then 6 over 6 is just 1. But this pre-existing negative sign is going to make it -1. So again, 6 over 6, just +1. Our negative signs canceled out, but that pre-existing negative sign is going to make our axis of symmetry -1. And that's just axis of symmetry. Now it says find the coordinates of its vertex. So our vertex is the highest or lowest point. So in this case, because it's a -3, we're actually working with a graph that looks just like this, a downward shaping U. And we know our x value, we know 2. But they want to know what our whole vertex is. So we still have to find our y value. Again, essentially all we have is -1 blank. What is our vertex? What is y? So moving on, it says, find the coordinates of the vertex. Since the equation of the axis of symmetry tells you x equals -1, and the vertex lies on the axis, the x coordinate for the vertex is -1. All they're saying is, now that you have a value for -1, plug it into your original equation and see what you get for y. Our original equation was y equals -3x squared minus 6x plus 4. Well, if x equals -1, plugging in -1 is going to tell me the second half of this pair. When x equals -1, what will y be? So y equals -3 times -1 squared minus 6 times -1 plus 4. -1 squared is 1. 1 times -3 is -3. -6 times -1 is going to be +6 plus 4. 6 plus 4 is 10. 10 minus 3 is going to be 7. So y equals 7. So if our axis of symmetry is -1 and our axis of symmetry is just the x value of it, we needed to solve for our y. We just solved for y. So now our vertex is just our two answers put together. Our vertex is -1, 7. -1, 7. And just to talk through one more time what each of these means. Your axis of symmetry is just the line that you draw that says if I fold my piece of paper right here, my graph is going to match perfectly on both sides. And it's just this x value because you're saying my line passes through this point on my x-axis. But then what's my actual vertex? What's my highest or my lowest point? Well, it's my x value and whatever I get for my y value, which is right there. All right. They then tell us to graph the function. Well, oh, nope. C now says identify the vertex as a minimum or maximum, which we've already done. Remember I said it's a -3. Because it's negative, it's going to frown, so it's going to be downward facing. If it's downward facing, we have a mountaintop, which means we have a maximum value. Then they say graph the equation, which I'm not going to do for the sake of time. We're already at 23 minutes. So you would go ahead and graph it same as you used to do. Plug in x values, generate y, keep going. All right, we're going to stop there. We're not going to do the matching test question, and that will be that. Good work, guys.